All right, so first off, I forked and cloned it, but last challenge, I forgot to do something I should be modeling from now on. So I'm going to open this up. And before I look at the problem, before I do any code, I'm just going to check out a new get branch. So open the terminal. So I'm going to get checkout -b. We can call this solution branch. There we go. So now any changes we make are going to be made to our solution branch, and our master branch will be kept clean so that we're not pushing directly to master at any point. So that's always an important thing to do. Now let's take a look at the problem. So we're going to create a function that takes a number parameter and returns the factorial of it. It says right here that's got a very specific definition. As an overview, a factorial is the result of multiplying a sequence of descending numbers down to 0. Factorials are only defined for non-negative integer numbers, but include 0. But 0 factorial is equal to 1. So the example here is 4. So 4 times 3 times 2 times 1 gives us 4. We can see this, follow this link. That gives us the Wikipedia definition of factorial. So it's essentially what we need to do is, given a number, we need to multiply that number by every number smaller than it by 1 up into down to 1. Does that problem make sense? So what I'm going to do now, have we talked about pseudocoding yet?
Not really.
Nope.
Mm-hmm. All right. Has anyone heard that word before?
Yeah.
Mm-hmm. How would you define pseudocoding?
Like writing out your thought process, or like writing out what you want to code.
Mm-hmm. Exactly. It's essentially writing out what you want to do step by step in just plain English. So we call it pseudocoding because you're using the same logic that you'll be using when you write code. It's just not technical. And you typically write that in comments. And so the idea is I want to model what I want to do, how I want to accomplish this step by step, no matter as granularly as possible. Because that's how the computer thinks, is granular. So we have our factorial function here. We have a number. It's an integer. We know it's going to be a positive integer or 0. And we're going to need to figure out a few things first. So what's our very first step after defining the function?
You need to multiply the number that you have by something.
So we're going to have to multiply the number we have by something. Yep. That's a good way to start thinking about it, but for pseudocoding, we're going to need some more concrete steps. So this is like we're writing the code, but we're just starting with, okay, what's the very first step here?
Establishing our output variable.
Yeah, we can define an output variable.
And then defining or establishing the base case for 0 and 1.
Mm-hmm. Yeah, so we know that 0 and 1, if we get those things, the answer would just be 1. So we could say if num is 1 or less than or equal to 1, return 1.
If you set your output variable as 1, could you skip that step?
We could also do that. So we could say define an output variable equal to 1. If num is less than or equal to 1, return output variable. Yeah. All right. Then we have our else. So if it's not less than or equal to 1, then what do we do? Taking our example 4, okay, we have an output variable equal to 1. We have a input number 4. What's our next step?
Be to run the math on it, right?
Run the math on it?
Yeah,
You can use the factorial function?
yeah.
We could do that. Yeah, there is a function that JavaScript we could do. I believe it's math.factorial, and that would solve the problem for us. But in this particular case, I want to make sure that we are, coding this ourselves rather than using it in a JavaScript method that does it for us. Because again, we want to take the car engine apart so we can see how it works.
Well, I mean,
Well, if it's anything greater than 1, we need to decrement and then multiply.
Decrement and multiply. Okay, that's good. How do we do that? What mechanism can allow us to do that?
A while statement.
A while statement? Okay. So while what?
Num is greater than 1.
While num is greater than 1.
Decrement num.
So decrement num by 1.
And then the output variable is multiplied by num.
You have to multiply and then dec.
And why is that?
Because if you decrement first, it'll never multiply by the initial value.
Yep. So if we look at our example 4 here, factorial includes 4 times 3 times 2 times 1. And since our output variable is already 1, we start with 4 times 3 times 2. And then we don't need to multiply by 1 again because it's already set to 1. Okay. And then once that's done, what's the next step?
Outside of the loop, return the total.
Then we return the output variable. Okay, so now we have a concrete plan going forward. We haven't written a single line of code yet, but we already have a solution kind of in mind. And the reason we do this is, okay, maybe like with something like Factorial, we could have just coded it as we went. That would have worked fine. But as we get to more complex problems, the more you'll find yourself wondering, okay, how do I do this? Where do I even begin? And pseudocoding is a great way to define your steps, define your things, and help you kind of conceptually break a problem down into smaller and smaller parts. And so that will save you a lot of time in the long run because it'll hopefully prevent you from running into dead ends. You'll still run into dead ends because sometimes a thing that logically makes sense to you isn't how the computer works or isn't how your coding language allows it to happen, but it gives you a way to move forward. So in general, it's a good idea to pseudocode before you write anything, if possible. And the other advantage is it always allows other coders, especially your instructors, to understand your thought process and figure out, okay, even if the solution didn't work, where was their head at? What questions do you have about pseudocoding? Okay.
Quick one. Is it generally considered good practice? Like where would you leave? Do you want to leave it above your code or like within?
So I don't know if there is necessarily a standard way to do that. One common thing people do is just kind of interpolate. So looking at our first step, we could say, let output equal 1. So we're literally saying here's my first step, here's me implementing it, here's my second step, here's me implementing it. That's one way to do it. Other people do put it all the way at the top or all the way at the bottom. It's kind of up to you. All right, any other questions about pseudocoding? All right. right, now we can just translate our pseudocode into actual code. So if num is less than or equal to 1,
You don't need the if-else statement because it's built into the while loop.
good point. So we could just say, if this, do this, and then we don't need to say else. You're right. Return output. And then here we can just say, I'm going to keep the else in the pseudocode, just so it's kind of there saying else, here's what we do. So in here I could say, while num is greater than 1, and in this case, I'm not going to keep on interpolating it because now we've got brackets and that's just going to get confusing. So we could say output times equals num. That's what multiply output by num. Then we can say num minus equals 1. I've forgotten if JavaScript lets you do minus minus or not.
I think it does.
They do.
They do? Excellent.
Yep.
So-
As long as you have a semicolon right tight next to it. Yeah.
I'm sorry?
Sometimes it gets fussy if there's not a semicolon on the plus plus or minus minus next to the variable.
Yep. Put our semicolon there just to be safe. So decrement num by 1, and then at the end we return output. All right. So let's go over this one more time, just to make sure we translated this correctly. Define an output variable that is equal to 1. That's what we did. If the number is less than or equal to 1, we return the output variable. If num is less than or equal to 1, return output. Then we have our while loop. While num is greater than 1, we multiply output by the number, then decrement the number by 1, and then we return the output variable at the bottom. We take a look at our spec file here. So we've got examples here of 8, 18, and 45. So it says, test how high of a number your program can calculate. Can we push it further? So before we do that, I'm going to usually do a couple things. First, I'm going to do a git add and commit just to make sure that I have this much progress saved. So git commit -m, added pseudocode and initial solution. So it shows me here I have 1 file change and 16 insertions added. Cool. Now let's run our tests. Node factorial spec. So we got true, true, and false. So it looks like our number can't calculate 45 factorial. And if I console.log, just see what it's actually returning. So fact.factorial 45. Let's see what it actually returns when it given a number that big. So I got 1.19622220864 times 10 to the 56th power. So it puts it in scientific notation at that point, which is not equal to this number here. So did anybody find a way to get this last test to pass? It's okay if not, because it's a bit of a pain, but it is possible. So what we have here is called scientific notation. So let's see if JavaScript has a native way to convert scientific notation into an integer. So JavaScript, convert scientific notation to integer. How to convert a string containing scientific notation to an integer. So that, what is the best way to convert it to a JavaScript format? Converting a number in scientific notation to a string. So let's hear, we have something called to locale string. Let's see if we can click on this link. Oh. So there's a method called .toLocale string. I'm going to test that out. So I'm going to copy this number here and then open up the node thing to make sure that method works the way I think it does. So so we could say, let number equal, we could say number dot to locale string. All right, so that gives us this. It's not exactly correct because it's got commas and is a string. So can we parse that into an integer? So I wonder if I did dot to int. No, it's parse int. Number dot to locale string. I don't know if this is going to work or not. Okay, that doesn't work. Because it looks like it just got 119 and then ignored everything after the comma. Okay, so this gives us some.
What was
Yes?
the documentation showing on that? There was a section for like full grouping.
Yeah, let's take a look. So they have .locale string full wide use grouping false. So let's see if I do. It's going to copy that, or just need the dot to locale string. So I do number. All right, so now if I do parse int, then pass in this whole string of things here. Puts it right back in scientific notation. Interesting. So
There's also like a crazy amount of zeros.
yeah,
Way more than in the
yeah.
answer.
Oh yeah, you're right. It's got a lot more zeros than our example here does. Because I think it looks like what it did is that it may have rounded it after the 2, and then it converted everything after that 2 into zeros. So it looks like this method isn't going to give us the solution either. Yeah, it says right here, number to locale string rounds after 16 decimal places. Okay, so that solution was interesting, but didn't quite work. I don't want to spend too much time on this, but I am curious, so. All right, looks like according to W3 schools, there is a .to exponential method.
I was able to pass that third test.
How did you do it?
I ended up using recursion. Well, me and Zach ended up using recursion.
So you made a recursive solution to Factorial, or?
Yeah.
Okay, do you mind walking me through that?
Yeah, it's actually pretty short. It's just 4 lines.
Okay.
So it's just, I just put an if statement. If num is less than or equal to 0.
If it's okay, let me.
Or sorry, 1. I guess it could be 1. Yeah, you can eliminate that. Let output equal 1.
All right,
so in the
return 1.
For the return, I just return 1. And then that's the end of the if. And then at the end, I return parentheses num times exports factorial parentheses num minus 1.
Like that?
Yeah. And you can comment everything else out.
All right, so this is a recursive example of recursive solution. Cool. And let's see if that passes the test now if we run this. Interesting, it does. I wonder why that is, because when we console.log our fact.factorial here, it still gives us the scientific notation.
I think it's because console.log is what's shortening it, and the comparison happens before, right?
Possibly. Yeah, I'm not sure. That's interesting. So yeah, this is a good example of a recursive solution to this problem. I know we're going to cover recursion in more detail later, so I don't want to fall down a rabbit hole of how this works, but this is definitely one way of doing that. So good job there.
We passed the third one with the Charlie. We just used a loop, just normal loop. And yeah, we just used the normal loop.
That
We
passed?
didn't. Yes, it passed. Yeah, like let I is equal to 1, and then I like something I is equal to or less than or equal to num, and just passing the like multiplying the numbers to total and just return total.
Oh.
Yeah.
Okay. So looks like there's definitely some kind of something here that prevents this one from passing the test, but I'm glad to see that there are other solutions that work. So, all right. What other questions do people have about Factorial? Okay. So in that case, let's take a break. Let's meet back here in 8 minutes. So let's start again at 9:50. And we'll talk a bit about Python fundamentals.